Thank you for joining us today. Welcome to the DX Today podcast, your no-hype source about artificial intelligence and digital transformation. We're diving deep into a topic that is, it's fundamentally changing how medical decisions are made: agentic AI in healthcare. For this deep dive, we've synthesized some extensive reports on this radical shift happening in artificial intelligence. We're moving from these, passive AI tools.
Like the simple prediction models we've seen for years.
Exactly. The ones that just spit out a number, a risk score. We're moving from that to truly autonomous systems. And these agents, they can set complex goals, they can develop multi-step plans, and they can execute these really intricate clinical or administrative workflows.
And crucially, they can do it without constant human supervision. That's the key.
That is the key. And this isn't just an incremental innovation. Our sources are calling it a necessity for the future of healthcare delivery. So today we're going to unpack exactly what these agents are, where they offer massive ROI, and critically why their very existence introduces this unprecedented crisis of accountability.
Yeah, the so-called moral crumple zone. We'll definitely have to get into that.
We will. It's a fascinating and frankly a terrifying concept.
What's so interesting here, I think, is that we're moving beyond AI merely serving as a tool. It's a fundamental repositioning of AI as a collaborator, a highly autonomous partner.
A teammate.
A teammate, exactly.
Yeah.
So we'll analyze the sophisticated technical architecture that actually gives these systems their agency, and then we have to examine the ethical, legal, and regulatory barriers.
Which, as the sources point out, are surprisingly much higher than the technical ones right now.
Much higher. I think the core thesis we're going to explore today is that agentic AI is really poised to reshape healthcare, and it's a big but, only if we as organizations and regulators can establish the robust governance that's necessary to support this high degree of autonomy.
Okay, let's unpack that seismic shift then. When we talk about agentic AI, we are really discussing a fundamental paradigm change in how these intelligent systems perceive the world, how they reason about it, and then how they act within it. So our mission for this first part is defining what specifically makes an agent an agent. How do we distinguish it from all the other AI tools that healthcare systems have been deploying for the last, decade?
Absolutely. And we have to move past this generic enthusiasm around the term AI and get really laser focused on the principles that define this new technology.
Yeah.
Because those principles imply vastly different operational and, as we said, legal risks.
Okay, so what are those principles?
Agentic AI is really defined by three inseparable core concepts. First, you have high autonomy. Then, a very distinct goal orientation, and finally, continuous adaptability.
Let's start with autonomy, because that is the defining word. It's frankly the one that's most intimidating for a lot of people in this space. It's what differentiates these systems from just being, fancy automation scripts.
It is the defining characteristic, yes. And we need a precise definition here. Autonomy means the system can independently set its own subsidiary goals.
So, sub-goals.
Sub-goals, exactly. It can make consequential decisions within a defined scope, and it can execute these complex, multi-step tasks with really minimal human intervention or oversight.
It's the ability to translate knowledge into direct action.
Into direct, orchestrated action. And crucially, autonomy means the system is not waiting for a human prompt for every single step. It manages the entire chain of action itself once that high-level objective has been delegated to it.
And that action is guided by the second principle you mentioned, goal orientation. I think a lot of people might confuse this with just simple instruction following, but it sounds like it's much more sophisticated.
It is, much more.
Yeah.
You don't just ask an agent to perform a single step. You delegate a massive high-level goal. For instance, you don't say, send the message. You say, manage this high-risk patient's post-operative recovery.
Wow, okay. Or optimize the throughput of the emergency department.
Precisely. The agent doesn't just sit there waiting for another prompt. It uses these sophisticated iterative reasoning and planning frameworks, often leveraging multi-step reasoning models like the reason and act or react architecture, to continuously break down that massive goal into a sequence of actionable, logical subtasks. It plans its entire strategy.
Okay, you mentioned the react framework. Could you elaborate on that a bit? Because I think understanding that cycle of reason, act, observe is just essential to grasping how the agent gets its agency. It's not just a big computer program running a script.
That's exactly right. It's a loop. Think of the agent encountering a situation. First is reason, The LLM part of its brain assesses the context, it consults its tools, its memory, its senses, and decides on the logical next move.
Okay.
Then comes act. It executes that decision. Typically, that means calling an API or triggering a communication or changing a setting on a device.
And then it has to see what happened.
Right. That's observe. It receives feedback on the success or failure of that action. Did the API call return the necessary data? Did the patient actually respond to the message it sent? And then that loop closes. It goes right back to reason, where the agent reflects on that observation and updates its internal plan or its trajectory for the next step.
And that iterative cycle is what allows it to handle the messiness and uncertainty of real-world clinical environments.
Exactly, which flows directly into the third defining principle, adaptability. This continuous feedback loop means the software is inherently dynamic. It is designed to change its behavior over time.
So it's not static software that's frozen at the moment you deploy it.
Not at all. The system is engineered to continuously perceive its environment, through new sensor data or API feedback, and to learn from the outcomes of its own actions. It adapts its behavior to new information or unexpected obstacles.
And that high degree of adaptiveness and self-correction is what makes it uniquely suited for the chaos of healthcare, where patient conditions and operational demands are changing, minute by minute.
That's right. And our sources are very firm on this. This capability is what makes agentic AI a necessity for future healthcare delivery, particularly in these new preventative and continuous care models.
Okay, that gives us a really solid definition of the autonomous agent. So now let's distinguish this action-oriented leap from what most of us already know. When people hear AI in healthcare, they usually think of tools they've been reading about for years. Predictive models or things related to the big generative models.
Right.
So how does agentic AI fundamentally differ from, say, predictive AI?
The crucial difference is that shift from passive forecasting to proactive execution. Predictive AI is powerful, don't get me wrong, but it is passive.
Yeah.
Its function is to forecast, and its output is a probability, a score.
Okay.
It might analyze a patient's history and their real-time data to output a score that says, they have an 85% risk of sepsis or acute deterioration within the next 12 hours.
So it gives you a huge warning flag, a critical piece of information. But the work stops there. A human has to then see that flag, interpret it, and then act on it.
Precisely. But an agentic AI system consumes that prediction as its starting point. It doesn't end there. It immediately takes the next step in the workflow chain.
So instead of just forecasting the risk,
it autonomously alerts the clinical team according to the hospital's pre-approved protocols. It might queue up a pre-approved diagnostic order, say, a set of lab tests directly into the EHR system, and maybe it even schedules a follow-up check by a dedicated nurse.
So it transforms a passive risk score into a series of actionable, multi-step interventions that are managed entirely by the system itself.
That is the action-oriented shift. Prediction becomes execution.
That distinction is just incredibly important for any organization thinking about ROI and, of course, liability. But what about generative AI? We are all using large language models every day now to draft emails or summarize articles. How does an agent go beyond just creating content?
Generative AI is, at its core, a content creation and text summarization machine. But it is fundamentally reactive. It waits for a human prompt, draft a clinical note summary, write discharge instructions, and then it generates content.
Okay.
And agentic AI orchestrates a massive multi-tool workflow, and it just uses that generative AI model as one specialized tool in its arsenal. The key conceptual difference for you to grasp here is the shift from using a tool to delegating a complex, high-level goal.
Let's use that type 2 diabetes management example from the source material because I think it really illustrates the depth of orchestration that's required here.
It's the perfect illustrative case study. So in a simple reactive generative AI scenario, a doctor might prompt the AI to, say, draft a polite, standardized response to a patient's portal message complaining about a high blood sugar reading.
Right. The human initiates the action and the AI completes that one single task, which is drafting the text.
Exactly. But with the agentic AI approach, the goal is delegated and the system becomes the orchestrator. The manager. The agent is given the high-level goal. Maintain this patient's type 2 diabetes within their target ranges and manage any unexpected excursions. The system then proactively monitors the patient's continuous data from a wearable glucose sensor or an in-home vital monitor.
Okay, so it's always watching within the approved parameters.
Always watching. And when a high blood sugar reading is detected that violates that patient's personalized treatment plan, the agent autonomously kicks off a sophisticated, multi-step workflow.
Okay, walk us through that workflow, because this is where the sheer depth of this agency becomes crystal clear.
So first, the system detects the reading, and it assesses the deviation against the patient's history and the protocol. That's perception.
Got it.
Second, it autonomously accesses the patient communication portal through an API. This is action 1. Third, it uses its internal generative AI component to graft a customized, personalized message of instructions.
Not a canned response.
No, not a canned response. One that's tailored to the patient's recent behavior and their specific protocol. That's action 2. Fourth, it sends the message and it logs the time.
But it can't stop there, right? Because a message sent doesn't mean it's a message received or acted upon.
Correct. So fifth, the agent then autonomously monitors the patient portal or the wearable data to see if the patient has acknowledged the communication or if their blood sugar reading starts to trend downwards. If not, step 6, it sends a time-sensitive reminder, maybe adjusting the tone slightly based on the lack of response.
And what if things get worse? This is the critical part.
This is the critical part. Seventh, and crucially, if the patient reports a specific, more serious symptom in response, let's say persistent nausea or dizziness, the agent automatically escalates the case. It alerts a human nurse, or it schedules an urgent virtual consult, initiating a complex new workflow entirely on its own.
Wow.
That entire sequence of independent perception, dynamic planning, using its tools like Gen AI, executing the plan, and then critically escalating, that is true medical agency.
It's the difference between having an AI write a sentence for you and having an AI run an entire proactive monitoring department for you. The shift is just monumental. It turns AI from a passive assistant into a proactive collaborator, a teammate, as the sources keep saying.
A teammate.
To manage that level of complexity, where actions have to be taken in a secure, high-stakes environment, these agents need a highly sophisticated technical backbone. I mean, a standalone large language model, an LLM, is basically just a very powerful calculator. It can't handle real-world interaction and accountability on its own. It needs a whole ecosystem.
It absolutely does.
Okay, let's look under the hood. Let's dedicate some serious time to this architecture, because this is where all the safety and governance mechanisms are actually built. The source material refers to the LLM as the cognitive engine. Why is the LLM the brain, but not the entire agent itself?
Because the LLM provides the indispensable core cognitive capabilities. It gives you robust reasoning, complex planning, and reflection. That react cycle we just walked through. It functions as the conductor or the brain, taking that complex medical goal like develop a treatment path for this patient's rare condition and using those iterative multi-step frameworks to logically break it down into manageable subtasks.
Without that reasoning capability, the agent couldn't really form a coherent or flexible plan of action when things get messy.
It couldn't. But pure reasoning based on static training data is, well, it's insufficient and it's potentially dangerous in a life-or-death environment. The LLM is trapped by its historical training data, and it has no inherent ability to interact with current real-world hospital systems.
Right, so to make that critical leap to agency, the LLM brain needs access to tools. The sources cleverly categorize them as its hands, senses, and memory. Let's start with the hands, APIs, application programming interfaces.
Yes.
How do APIs serve as the agent's way of executing actions inside the secured, complex hospital infrastructure?
They're the only way the agent can safely act in the real world. Through secure, audited APIs, the agent connects directly to sanctioned external systems. It can query the electronic health record, the EHR, for the very latest patient demographic or lab data. It can update scheduling software for follow-up appointments.
And in the most advanced cases, it could even control devices.
In the most advanced and highly regulated scenarios, yes. It could control the settings and functionality of connected medical devices, like infusion pumps or ventilators. This API layer is how the agent actually executes the subtasks the LLM has planned. It's what transforms abstract thought into tangible operational change.
Okay, now let's talk about memory, specifically the trusted authoritative memory layer. The source material really emphasizes retrieval augmented generation, or ARAG. This doesn't just sound like a technical add-on, it sounds like a fundamental governance and safety feature.
ARAG is absolutely critical. It is the agent's external trusted memory, and you are exactly right. It is the fundamental anti-hallucination control. An LLM, if you leave it unsupervised, will often confidently generate plausible but factually incorrect information based on its generalized training corpus. That phenomenon we call hallucination.
Which is completely unacceptable in healthcare.
Completely. So ARAG grounds the LLM's reasoning process. Instead of relying only on its internal static training weights, The agent is forced to perform a retrieval step first.
So how does that work technically?
It searches through curated, authoritative knowledge bases that live inside the hospital firewall. These are specific databases, maybe they're structured as knowledge graphs or indexed via vector search, but they contain only approved hospital protocols, the latest peer-reviewed medical literature, or specific patient health record data.
So it's forced to look at the approved playbook first.
Yes. The LLM retrieves the relevant, trusted data snippets, and then it incorporates them into its response or its action plan. This prevents it from straying into generalized or faulty territory. This technical mandate builds trust and evidence-based governance into the system from the very beginning, from the architecture.
That is a fascinating insight. So RAG isn't just about accessing better information. It's a deliberate technical mechanism to overcome the inherent structural failings of generalized LLMs when the stakes are this high. It makes the decision auditable.
It ensures the decision is localized, evidence-based, and protocol compliant, rather than based on generalized and often outdated training data. And this puts a huge onus on the data governance team to make sure that those RAG repositories are maintained, comprehensive, and continuously updated.
Of course. And finally, the agent needs its senses to perceive the ever-changing clinical environment in real time.
That's the perception layer. Agency requires continuous awareness. In a hospital setting, this means integrating real-time data streams from wearable devices, sophisticated IoT biosensors that are monitoring vital signs, in-home monitors for remote care, or continuous feeds from specialized hospital equipment.
And this constant stream of sensor data feeds right back into that react loop we talked about.
Directly. And that's what allows the agent to be truly proactive and adaptive. It can initiate action based on sudden, real-time changes in a patient's status, rather than just waiting for a scheduled human assessment every few hours.
A single, powerful agent sounds like a marvel, capable of handling a significant workflow. But medical problems are inherently complex. They often require the coordination of multiple specialists. How does the agent architecture scale to handle that kind of complexity, especially integrating multimodal data?
That's where we move from a single agent to multi-agent systems, or MAS. For these large, complex medical problems, like synthesizing data from a patient's genomic tests, their imaging results, and their physiological monitors, a single, monolithic agent is just too inefficient. It's too fragile.
So the solution is a decentralized architecture.
Yes, where a team of specialized agents collaborate. Our sources refer to this as the agent swarm model, and it's directly analogous to a human multidisciplinary care team, like a tumor board.
So instead of one general-purpose physician agent, you have specialists that are coordinating their findings autonomously.
Precisely. You would deploy specialized agents focused on distinct areas. You'd have a dedicated radiology agent that only interprets imaging studies, a molecular test data agent that decodes complex genomic results and proteomic data, and maybe a clinical data specialist agent focused solely on analyzing unstructured clinical notes and charting the patient's social determinants of health.
And how do they talk to each other?
These specialized agents communicate via established protocols. Often it's using internal message passing or a shared context memory. They coordinate their actions, and they synthesize a comprehensive, multimodal patient picture that no single agent could build on its own.
And is there proof that this architecture is actually better than just trying to build one giant monolithic AI?
Oh, yes. Studies consistently show that MAS significantly outperforms single-agent systems in complex prediction tasks, things like mortality prediction, length of stay forecasting, and synthesizing diagnostic evidence. The value of distributed intelligence, where different models are specialized and focused, dramatically enhances the overall reliability and accuracy of the system in the highly complex domain of healthcare.
So this modular collaboration is key to scaling agency responsibly.
It is, and we can't forget how they continuously learn and improve their policies over time.
Right, the cognition layer.
Exactly, the cognition layer. It often uses techniques like reinforcement learning, RL, or iterative fine-tuning. RL allows the agent to continuously learn from the outcomes of its actions. So, for instance, if an intervention strategy led to a better patient outcome, that strategy is reinforced. It's prioritized in future planning.
So the agent deployed today should theoretically be slightly better than the agent deployed 6 months ago.
It should be, provided the governance is tight. This is the technical mechanism that allows the system to adjust its internal decision-making policies to match evolving clinical demands and new knowledge. It ensures it remains a truly continuously learning ecosystem.
Okay, let's move from the technical blueprint to the actual patient benefit. Let's explore where this agency translates into massive clinical value. The recurring theme here seems to be moving beyond automating one small task to orchestrating entire complex clinical workflows. This is where the ROI becomes truly compelling.
Indeed. The value proposition of agentic AI is not doing one small thing slightly better. It's managing the entire continuum of care for a specific high-stakes situation, and often doing it outside the traditional walls of the hospital.
Let's start with what feels like one of the most mature and highest impact applications: autonomous patient monitoring and intervention. This is really the definition of preemptive care.
This is where agentic AI fulfills its promise as a true digital extension of the care team. These systems are not confined to the hospital. They continuously synthesize data streams from wearables, remote monitors, smart scales, patient-reported outcomes, creating a 247 surveillance capability.
And the agency lies entirely in the proactive response to that data.
Entirely. The system doesn't just generate a dashboard warning. It determines and executes a course of action.
Can you give us some specific, detailed examples of that autonomous action in a high-risk scenario? Let's make it concrete.
Okay. Consider a patient who was recently discharged after heart failure. The agent is monitoring their vital signs, their weight, and their perceived exertion from home. If the agent detects a concerning combination, let's say sudden weight gain combined with dropping oxygen saturation.
Okay, classic warning signs.
Classic signs. It predicts decompensation hours or even days before a human would spot it from a weekly check-in. And based on pre-approved, highly regulated protocols, the agent can autonomously initiate multi-level interventions.
What kind of interventions are we talking about?
It could be something simple, like automatically placing an urgent call to the patient to assess symptoms. Or it could be more advanced, like initiating a video consultation with an on-call nurse. It could even increase the frequency of vital sign monitoring automatically.
And what about connected devices?
If it's connected to a smart device, like an at-home non-invasive ventilator, it could autonomously adjust the pressure settings to stabilize the patient temporarily until human help arrives.
This continuous preemptive surveillance has massive quantifiable implications for hospital operations.
Absolutely. It fundamentally shifts the model from reactive care, waiting for the patient to show up sick in the emergency department, to preemptive care, where you're actively anticipating and preventing the complication. Studies have shown this approach significantly reduces high-cost, disruptive hospital readmissions.
Which directly impacts the bottom line, while improving patient outcomes and their quality of life.
Exactly.
Okay, next, let's look at personalized treatment planning and diagnostics. This requires handling just enormous amounts of multimodal data that no single human could possibly synthesize in a timely fashion.
This is precision medicine delivered at scale, and it is a massive undertaking. Agentic systems synthesize these disparate data types: genomics, real-time physiological outcomes, long-term lifestyle factors, comprehensive EHR data to dynamically adapt treatment plans to the individual. We're moving past the idea of generalized treatment pathways.
So how does that look in a high-stakes field like oncology, where treatment decisions are constantly evolving based on new research?
Oncology is a perfect use case because these agentic systems can digest complexity at incredible speed. They can analyze a tumor-specific genomic mutations, its epigenetic markers, its immune response profile.
And then cross-reference that against what? The entire medical literature.
The entire global corpus of medical literature, yes. And active clinical trial data and internal hospital outcome databases. This allows the system to recommend a highly personalized dynamic treatment protocol.
So it might suggest a specific combination of targeted therapy and immunotherapy that is tailored to that individual's unique biological fingerprint.
Exactly. Moving far beyond the standardized one-size-fits-all treatments. The human oncologist, of course, reviews and approves the AI's proposal, but the synthesis of all that data is driven entirely by the agent.
And the adaptive nature seems especially useful in managing chronic conditions or mental health, where a patient's needs can change hourly or daily.
Take mental health management, which is desperately short on human resources. An agent can monitor symptom scores, compliance data, biometric indicators from a patient's digital therapeutics app.
And based on that real-time data.
And a continuously updated risk profile. The agent can autonomously route users. It can send those with rapidly worsening high-risk scores immediately to a prioritized queue for in-person or telehealth therapy.
While guiding those with lower stable scores through automated modules.
Exactly, guiding them through personalized, automated psychoeducation modules, digital journaling exercises, or mindfulness strategies. It is a highly personalized, adaptive orchestration of care that scales those limited human professional resources much more efficiently.
The diagnostics field is also being transformed. We're moving beyond simple image classification in radiology, which has been pretty standard for several years now.
The shift here is toward an end-to-end diagnostic workflow. We're granting the agent responsibility for the entire process, not just one single step.
So agentic radiology moves from classifying one image to managing the overall diagnostic pathway.
Yes. The agent can autonomously select the correct imaging protocol based on the patient's EHR and their history. It can analyze the images and generate a draft report that's focused on the most critical findings.
But as we discussed with the multi-agent systems, the critical piece has to be the data correlation.
Exactly. The agent uses that multi-agent structure to correlate those imaging findings with pathology reports, with genomic sequencing data, with complex lab results. This synthesis builds a holistic, multimodal picture that allows the agent to propose and support a complex differential diagnosis.
Something that might be easily missed or delayed by a single human clinician who's focused only on one siloed data type.
Precisely. That capability, the correlation across massive, disparate data sets, is where the real diagnostic advantage lies.
Okay, finally, let's turn to the next frontier and perhaps the highest stakes application of all, the agentic-assisted surgeon. This sounds like the ultimate test of medical agency.
This is the cutting edge, for sure. And while it's still largely experimental and highly regulated, the developmental trajectory is clear. Current robotic surgery systems, like the Da Vinci platform, are phenomenal tools that enhance human dexterity.
But the surgeon is in full moment-to-moment control.
Full control. The agentic vision, however, implies true, real-time, autonomous adaptation within the surgical field.
So what does that mean?
It means agentic surgical systems are being designed to integrate and analyze real-time intraoperative feedback. Things like tissue tension readings, camera feeds, perfusion rates, unexpected anatomical variations.
And based on this continuous perception, the system will dynamically and autonomously adjust the robotic arm movements.
At a level of precision and speed that's beyond human capability. The system could automate these highly repetitive, precise steps of a procedure, like complex suturing or tissue dissection,
freeing the human surgeon to focus solely on the most critical, strategic, and variable aspects of the operation.
Yes. This represents a gradual, but I think a certain move toward highly autonomous robotic surgery, managed and overseen by a human supervisor.
While those clinical applications are thrilling and high stakes, the source material makes a really powerful argument that the most immediate, highest ROI, and strategically important application for agentic AI is actually in solving healthcare's crippling administrative crisis. This is what they call the Trojan horse for enterprise adoption.
We have to acknowledge the scale of the administrative crisis first. I mean, this isn't just a minor annoyance. It is a systemic drain on the entire industry.
The scale is staggering. The U.S. healthcare system spends over $1 trillion a year just on administrative costs. This burden is not only a massive financial drain that inflates patient costs, but it's also cited as the primary driver of clinician burnout and dissatisfaction.
Humans are spending hours on repetitive data entry tasks that contribute absolutely nothing to direct patient care.
And the data supports the priority. 57% of physicians identify addressing this administrative burden as the single top opportunity for AI deployment. This is about operational survival as much as it is about efficiency.
Exactly. And agentic administrative systems are designed to reclaim that time by automating complex, repetitive knowledge workflows. These agents function as highly proactive, integrated digital teammates handling tasks that require reasoning and external interaction, not just simple data input.
Okay, let's look at how these systems specifically reclaim clinician time. Let's start with the overwhelming flood of patient portal messages, refill requests, and all those general communications.
This is a perfect application for intelligent triage and response agents. Instead of human staff having to sort through hundreds of messages every day, the agent can autonomously process, prioritize, and respond to a huge portion of them.
What can it handle on its own?
It handles common FAQs, it can route prescription refill requests directly through the EHR's pharmacy module, it can manage scheduling changes. But crucially, it uses its reasoning capabilities to escalate only the complex, high-acuity communications that absolutely require a clinician's expert time. It filters out all the noise.
And moving beyond that initial contact, the agents can manage the logistical workflows that are currently responsible for so much inefficiency.
They handle the end-to-end management of longitudinal care logistics. Things like scheduling follow-ups based on protocol compliance, sending personalized educational reminders, and managing those complex task handoffs between different specialists and care team members.
That's a huge source of errors.
It's a massive source of inefficiency and potential patient harm in large hospital systems tasks, falling through the cracks during shift changes or specialist referrals. The agent ensures continuity and compliance.
We often hear about AI scribes. But how does agentic AI push autonomous documentation beyond just simple transcription into true workflow automation?
Simple transcription just creates a text file of what was said. Agentic documentation goes much, much further. The agent can autonomously attend the virtual or in-person patient encounter. It summarizes the complex history and conversation. And then, this is the key step, it structures and inserts that data directly into the correct specific fields and billing codes within the electronic health record.
So it eliminates the tedious cognitive overhead of structured data entry that clinicians hate.
Exactly. It allows them to focus entirely on compassionate, patient-facing interaction.
These are significant operational efficiencies. But the financial health of an organization often hinges on revenue cycle management, RCM. Can agents truly manage this complex, high-stakes financial process?
Autonomous revenue cycle management is arguably the single highest ROI area for early agentic deployment because it deals with such massive complexity, scale, and financial risk. Agentic RCM systems manage the entire claims lifecycle from pre-service estimation and prior authorization all the way to final denial management.
So what is the most valuable, proactive thing an agent can do in that RCM lifecycle?
It's the ability to proactively prevent denial submissions before they even happen. Current systems typically react to denials after the fact. Agentic RCM systems are designed to continuously learn and adapt to new billing rules, coding requirements, and most importantly, highly granular payer-specific denial patterns in real time.
So it sees patterns that a human team might miss.
Patterns a human team could never see at that scale. By spotting the evolving patterns and small variances that lead to rejections, like a missing modifier code or incomplete documentation, the agent automatically flags and corrects the claim before it's submitted. This maximizes first-pass clean claim rates and significantly strengthens the organization's financial health.
So we circle back to the strategic implication, the Trojan horse. Why are these administrative wins the necessary gateway to clinical adoption?
Because they are lower risk, they're easier to validate, and they offer massive, immediate, and measurable ROI. The beauty of this strategy is that by deploying administrative agents first, the health system is forced to build the necessary foundational infrastructure that will be required for the high-stakes clinical agents later on.
What specific infrastructural elements are we talking about? What gets built during this Trojan horse phase?
You have to build secure, audited API integration with the EHR, which is necessary for both RCM agents and clinical diagnostic agents. You must establish robust data governance frameworks to ensure data quality and lineage. You have to deploy advanced security controls. And critically, you have to train the organization's staff and leaders to trust autonomous systems and establish those first critical AI governance committees.
So once that secure, high-governance infrastructure is in place, the cost and complexity and the perceived risk of deploying higher-stakes clinical agents later become exponentially lower.
Exactly. The path to clinical transformation is not paved by code alone. It is paved by first solving the administrative crisis and building that foundational trust.
The transformative power of agentic AI is, it seems, matched only by the scale of the ethical and legal risks it introduces. We established that the high degree of autonomy is, ironically, the single greatest barrier to widespread adoption in the most critical clinical settings.
And this brings us directly to the core conflict that is preoccupying legal departments all over the world, the question of liability. And it's framed by these twin issues of the opaque black box and the impossible position of the moral crumple zone.
This is the central crisis that health system executives have to address. When an autonomous self-learning agent makes an error that results in patient harm, say missing a critical subtle diagnosis or failing to escalate a critical change in status or recommending a dangerous dosage based on faulty data, the traditional malpractice frameworks completely break down.
They do.
Why do they fail here? They're built on the concept of a human standard of care.
They fail because the decision that led to the harm was made by an opaque black box algorithm. Even the clinician supervising it cannot fully explain or interpret the complex internal logic or the specific chain of reasoning that led to the error. You can't hold the machine itself liable, and you can't easily prove that the human clinician deviated from the standard of care because the error originated upstream in the algorithm's autonomous planning or its learning process.
And this is where that concept, the moral crumple zone, enters the conversation, placing the human clinician in an absolutely impossible position.
It is a terrible term for a very real and dangerous problem. Because the legal system has to assign blame somewhere, and because the algorithm is opaque, the legal and moral blame is inevitably crumpled onto the nearest human, the supervising clinician, the physician, or the operator.
So they're held legally liable for failing to catch the AI's error.
Exactly. Which seems entirely untenable and profoundly unfair. The clinician is being held accountable for a decision they didn't actually make, that they couldn't fully comprehend the rationale for, and which they may not have had the time or the training to successfully override.
It creates an uninsurable systemic risk for health systems. How can you insure against liability arising from a system whose logic and decision trajectory are inherently designed to change and evolve after you deploy it?
You can't, not under current frameworks. Resolving this liability crisis by establishing new, clear legal frameworks that assign responsibility to the manufacturer or the health system or even the AI itself is arguably the single most important action needed to unlock the safe potential of high-stakes clinical agentic AI. Until this is sorted, legal counsel will remain the primary impediment to adoption.
Beyond liability, the high autonomy of these systems brings algorithmic bias right to the forefront, risking the amplification of existing harmful health disparities at a systemic level.
This is a critical, high-stakes risk that must be governed proactively. AI systems are inherently trained on historical data, and that data reflects decades of systemic and historical bias in healthcare delivery.
Data that might be skewed toward wealthy, urban populations, or lack diversity in genetic datasets, or exhibit historical patterns of underdiagnosis in specific demographic groups.
Yes, and if an autonomous agent learns and operationalizes these historical biases without human oversight,
It codifies them and operationalizes them at machine speed.
leading to systematically inaccurate diagnoses or suboptimal treatment recommendations for underserved populations. An autonomous agent trained on unrepresentative data can learn and perpetuate health disparities without ever realizing it. For example, if an agent is trained disproportionately on light-skinned patients, its ability to accurately detect subtle dermatological issues in dark-skinned patients will be impaired, leading to delayed diagnoses that are systematically propagated across millions of patient interactions.
So mitigation requires strong organizational mandates for rigorous testing, representative training datasets, and adherence to established fairness and equity frameworks.
It's non-negotiable.
Let's discuss patient autonomy, because it's really challenged by this black box problem. The very foundation of medical ethics relies on truly informed consent.
That's profound conflict. Informed consent requires the patient to understand the risks, the benefits, and the alternatives of a procedure or a recommendation before they agree to it.
But if the clinician, because of the black box nature of the agent, can't fully explain the internal logic or the probabilistic trade-offs or the specific risk profile of the AI recommendation,
Then how can the patient give truly informed consent? It erodes a patient's fundamental right to autonomy, and it chips away at the trust that defines the entire patient-provider relationship.
so transparency, or explainable AI, XAI, becomes not just a technical feature, but a legal and ethical prerequisite for using these agents.
Absolutely. The mitigation strategy has to include radical transparency regarding the agent's role. It means new patient education protocols designed to demystify the technology and consent forms that explicitly document the role the AI is playing in the formulation of the care plan. XAI must be engineered to provide explanations that are actionable for the clinician and understandable for the patient.
Finally, we have to touch on data privacy and security. Agentic systems require autonomous, continuous, and deep access to vast amounts of protected health information, PHI, across multiple hospital systems just to operate effectively. That sounds like a massive and continuous IPA compliance challenge.
It is perhaps the most significant operational challenge. The core governance task is ensuring end-to-end HIPAA compliance for workflows that are executed entirely autonomously, without a human logging in and out for every single step.
Which means you have to build exceptionally strong technical safeguards directly into the agent's architectural design.
They have to be built in.
What are those specific safeguards that are non-negotiable for autonomous operation?
First, you need dynamic, context-aware access controls. This means the agent can only access the minimum necessary PHI at the precise moment of action. For instance, the RCM agent only needs billing codes and insurance data, not the patient's clinical notes, unless a specific denial requires it.
Okay, what else?
Second, you need hybrid PHI sanitization methods to anonymize data that is used for the agent's continuous learning and improvement without violating patient privacy.
Mm.
And third, and critically, you need immutable, cryptographically secured audit trails that log every single autonomous decision, every data interaction, and every API call for continuous compliance monitoring and regulatory review.
So compliance can't be an afterthought. It has to be the central, non-negotiable architectural requirement from day one.
It has to be.
Navigating these profound risks, the liability crisis, the bias amplification, the consent challenge, this requires entirely new regulatory thinking, especially since traditional regulation was designed for static software that doesn't change after it's been approved. The sources point to the FDA being quite proactive in developing adaptive frameworks.
The FDA recognized very quickly that their traditional paradigm authorizing a locked device that cannot be changed without an entirely new submission was obsolete the moment they started considering self-learning autonomous AI.
Because an agent is fundamentally designed to learn, adapt, and change its internal parameters after authorization, the regulation has to accommodate that adaptive nature safely.
It has to. And the core regulatory innovation that addresses this, that allows agency to exist within a compliant framework, is the Predetermined Change Control Plan, or PCCP. This is a mechanism to regulate continuous learning.
The PCCP is the central innovation for regulating adaptive AI.
It is. Instead of requiring the manufacturer to resubmit the entire device for review every single time the algorithm learns a new pattern or adapts its planning process, the manufacturer proposes a PCCP in their initial submission, which the FDA pre-approves.
So what exactly does that pre-approved plan entail, and how does it provide safety?
The PCCP defines the sandbox. It defines the specific boundaries, or the guardrails, for the agent's autonomous modifications. The plan has to be rigorously focused and bounded, which means the agent's continuous learning is restricted to pre-approved safe parameters.
For instance,
The agent can autonomously retrain on new patient data to optimize its prediction accuracy. That's a focused change. But the PCCP would strictly forbid it from fundamentally changing its core diagnostic algorithm or expanding its use case to a new patient population. That would be a change outside the approved bounds.
So as long as the agent's autonomous changes stay within these pre-approved bounds, the device remains compliant without constant resubmission.
Exactly. It seems like an incredibly smart way to balance innovation and safety. It allows the system to adapt and improve without compromising the core safety features the FDA initially validated.
It provides the necessary autonomy while ensuring accountability remains tethered to that pre-approved plan.
Right. And furthermore, the FDA emphasizes adherence to good machine learning practice, or GMLP, which provides 10 guiding principles for safe development, deployment, and monitoring. And 2 tenets of GMLP are particularly salient for agentic AI.
What are those key GMLP tenets that dictate how these agents have to operate?
First, there's a strong mandate that all clinical study data and training data sets must be representative of the intended patient population. This is a direct regulatory mandate to mitigate algorithmic bias at the source, forcing manufacturers to address fairness before they deploy.
And the second one?
Second, and critically, the focus is placed on the performance of the human AI team. The regulators are not just evaluating the AI in isolation, they are mandating a rigorous human-in-the-loop design, explicitly acknowledging that human oversight, interpretation, and ethical judgment are essential for safe operation.
This emphasis on the human AI team brings us directly to the imperative for trust and collaboration, which is the necessary prerequisite for actual market adoption. You can have the best technology in the world, but if clinicians and patients don't trust it, it fails.
Absolutely. And transparency, driven by explainable AI, XAI, is non-negotiable here. Clinicians and patients need clear, understandable, and timely explanations for the AI-driven recommendations and actions to trust the output and to maintain ethical standards. This transparency is the link between the black box and informed consent.
Which brings us back to the most realistic model for adoption right now, the hybrid or human-in-the-loop approach.
The HITL model is the essential current safeguard. Agentic AI should not be viewed as a replacement for human expertise, but as a teammate. It's about balancing powerful, high-speed automation with the indispensable human judgment, empathy, and ethical expertise.
So the AI is the orchestrator of complex workflows and the synthesizer of massive data.
But the human remains the manager of the system, the interpreter of complex insights, and the final ethical decision maker.
So the role of the clinician changes fundamentally. They stop being the performer of every single task, many of which are tedious and administrative, and they move into a completely new, higher-level role.
The clinician evolves into a manager of systems, an interpreter of complex AI-driven insights, an ethicist, and a strategic decision maker. The human provides the empathy, the complex judgment in ambiguous cases, and the emotional connection, while the agent handles the high-volume orchestration and automation of the technical workflow. This synergistic collaboration is what will define the future of high-value medical practice.
We've covered the technical architecture, the high-stakes clinical workflows, and the profound legal and regulatory risks. Let's synthesize the ultimate value proposition that is driving this massive wave of investment and transformation.
Let's start with the economic impact. What is the measurable financial incentive driving health systems to undertake this complex transition?
Well, the potential for economic impact is enormous. It's the primary driver of C-suite interest, no doubt. Estimates suggest AI could contribute somewhere between $100 and $150 billion annually to the U.S. healthcare system through realized efficiencies.
And that value stems directly from two key areas. Those massive administrative and operational efficiency gains, the RCM and triage wins we talked about.
And significantly reduced downstream costs due to improved clinical outcomes, fewer readmissions, earlier intervention, and proactive, continuous care.
You mentioned a virtuous cycle created by this technology. How exactly do the economic and clinical benefits feed into each other in practice?
It's a clear logical progression that really compounds value. Automating administrative tasks directly reduces clinician burnout, and it frees up professional time.
And less burdened clinicians have more mental and temporal bandwidth for compassionate, patient-facing care.
Exactly. When this restored human capacity is combined with AI-powered diagnostics and proactive monitoring, it leads to earlier, more precise diagnoses and personalized treatments. And that significantly reduces the need for high-cost, late-stage emergency interventions, complications, and expensive hospital readmissions. The cycle connects saving money with simultaneously improving the quality and compassion of care.
So for leaders listening to this, what are the key strategic imperatives they should be focusing on right now to prepare for this autonomous future?
First, they have to close the readiness gap. While investment in generative AI is projected to triple by 2026, many organizations are still playing catch-up. Only about 18% consider themselves truly AI-ready. The strategic priority is not deploying the most advanced experimental clinical agent. It's building the foundational infrastructure.
Secure data governance, robust API integration with existing systems, a culture of data quality. Infrastructure must precede innovation.
Infrastructure first. What is the second critical priority, particularly given our liability discussion around the moral crumple zone?
Governance first. Health leaders must establish robust, well-funded, and independent AI governance committees and bias review boards before they deploy autonomous clinical systems. This is the organizational defense mechanism against both the moral crumple zone and the amplification of algorithmic bias. You must have a clear process for auditing, validating, and establishing the accountability boundaries for the systems you deploy.
And the final, broader imperative is policy action to address the liability crisis itself.
Absolutely. Health system leaders must advocate for and collaborate on policy changes to create new legal frameworks that can fairly assign liability for autonomous agent actions. We have to move beyond the untenable position of the clinician being the default moral crumple zone. Policy clarity is required to provide the legal confidence necessary for broad, safe clinical adoption at scale.
So we've seen that the trajectory is clearly moving towards a continuously learning healthcare system where autonomy is the backbone of efficiency and proactive care. But this journey is just defined by complexity and risk.
But that success depends entirely on organizational governance, not just on the brilliance of the code. The source material ends with this really fascinating, actionable concept about how forward-thinking organizations should strategically handle this transformation. They should mobilize an agent factory.
An agent factory, what does that mean?
A centralized, dedicated group with direct C-suite support, focused purely on the continuous building, rigorous validation, and ethical governance of these autonomous agents, treating them as industrial products rather than one-off IT projects.
That idea of a dedicated internal agent factory is something for you to mull over. It suggests that managing the process of agency, rather than simply buying off-the-shelf tools, will be the true competitive differentiator in the next decade of digital transformation. The organizations that succeed will be the ones that master the internal engineering of trust and accountability.